Hello? Lovely. We've got a big one going on today. Okay, it's been a long journey because of what BitTensor is and what we're ready to compromise. So BitTensor suffers a problem of attention. And it's one of those things that's existential because we reject tools that will corrupt us. Everyone wants to build the next BitTensor. They discount all our achievements. The world doesn't owe us shit. A lot of times, people will ignore us. People will say we're fraudsters, scammers, or whatever. But if you keep pushing, you will do the undeniable. They can't call bullshit. Now, we're far from our journey of where we want to be. So let's take a step back. What do we want to do with decentralized trading? It's important we understand, like, what is the prize? What are we fighting for? We want to democratize. No, let me take a step back. If creating large language models, if AI is the future, then the ability to forge large language models, especially pre-training, which is by far the most expensive and most complicated bit of LLM training, is the most powerful thing in the world. There are maybe 5 to 10 companies that can do it at scale. What they say is, right, we're at least 300 to 1,000x behind centralized parties. But what they not notice is the gap between this year and last as we accelerate. We're just getting started. In 9 months, we had gone from 1.8B to 72B. That's about 30x. We're going into the acceleration phase of decentralized training. We will harness all the compute on the internet and we will train models. Jack Clark and Epoch AI recognize us as the largest by far. I think the runner-up is News, and they're 40, and they've gone back to, I think, 32. I don't really track them anymore. So, why is this important? Because what I'm going to try to attempt to do, because we are in a very funny place in that the research is our product until we're revenue ready. So it's important we communicate our stories and achievements and why they matter, probably even more than everyone else. Because, you see, things happen and you keep growing. But Subnet 38 just got to register today. I think they did good work, but they made the fatal mistake I almost made. That's that if my code works and it's good, people will give a shit. No one will give a shit. You need to make people understand. And it's very hard for us. So if it's harder for us to research, we need to spend just a lot more time. Let me set the stage of not just Templar, but the wider picture. Right now, if you want to train a big model, you need to get co-loc, not just normal, it's not even also about GPUs. It's GPUs that are tightly networked. They must be co-located. You need to worry about the storage. You need to worry about heating, energy, and everything. So when you look at the cost of training your large language model, you also look at the cost of the data center that need to be amortized over however many years before that technology becomes outdated and they need to switch it. So it's crazy expensive. So what is decentralized trading? Decentralized trading is saying, can we not have a data center? Because it is not even the GPU costs that are the barriers to other people being able to train. It's saying that if you need 1,000 GPUs, those 1,000 GPUs have to be in the same building. They need to be next to each other or very close, like literally almost welded together. So what we do is, and that is what is powering the future now. So we say, okay, guys, cost is rich, but it's not data center rich. I am poorer by orders of magnitude. So we said, okay, how do we do this? We said, okay, what if we could train over home broadband? What if we could somehow figure out how to get all these GPUs we need? What if we can just communicate over the internet and get them to converge, get the model to train? So that's what we did. I read the initial version of Templar. Oh my God, it was so broken. But eventually that became Gauntlets about 3 months later. And what did we innovate on? We innovated on the permissionless layer because it's important to us. When we commoditize intelligence, it should be a public good, free from any kind of encumbrances and built on credible neutral grounds. So that was it. What's the next problem we handled? We were still unbelievably slow. But for the first time, we had permissionless training. Permissionless training was important to us, but not to the AI world. And that was okay. It's important to understand how we get here. Now we understand what's the next problem. How do we do this efficiently? No one's going to train a model. I think Templar 1 would have trained, like if you try to do Templar 1 on this, it'd be interesting if research could give me that number. I don't know what that number is, but I'm sure it's over a year. It would take to train a 72B. 100% sure. So what did we do? We said, okay, let's innovate on the communication layer, on the data layer. So on the communication layer, let's build a new optimizer. Because at that time, we had used News's demo, and it was okay because back then we didn't know better. But as we went down that line, we realized the problem with News's demo, it was very good at compressing information. So after you train, you send a decentralized training protocol. It's going to be something like this. Do X for X amount, then communicate it. So you train for X amount of time, then you communicate it. With News's protocol, what happened is you train for one step, and in that step, you communicate it. Very important. Because when you train, you want your training to be as long as possible. But imagine if you're going, and beep is like every time I'm quiet, that's when I'm training. So beep, then it means that we're beeping when we can be training, or we're transmitting when we can be training. At the other end, we had private and everyone else. But what advantage does Demo have is that they can compress 99%. So we work with the local. The local is interesting because it allows you to train a lot longer before you have to communicate and exchange gradients. That means you go from training 50% of the time to training 99% of the time and communicating just 1% of the time. So what happens when you take these two properties? Compression means we can use cheaper bandwidth and do things faster, but also local steps, taking local steps, which is you don't broadcast every time. You train, I only beep after like 500 steps. That brings back to SparseLoCo. Now, what I'm describing to you high-level concepts. It doesn't map out to the reality of what research had to do, what Yazan and Amir and their collaborators had to do to get this to work, because Demo and DeLoco did not map properly together. It just didn't work. They had to invent crazy amount of stuff. And that gave us SparseLoCo. SparseLoCo is by far the most sought decentralized training learning algorithm in the world, hands down. That's what we used to train Covenant 72B. But you don't still get attention because we don't have that narrative capture. We got to Neuro IPS, it was fun and everything. So now here's the thing, and that's what got us the attention. We couldn't get this narrative because we were no one. But all of a sudden, there's going to be some random person on the internet that just said, wow, what I want to do this, people playing it. I just realized that these people, this set of misfits, this underdogs are training, they're by far ahead of everyone else. So that thing doesn't mean that the job is done. But I think even for me, it's a lot of validation that keep working at it, don't give up, do honest work. And for me, it's very personal because I'm a normal person. I'm not even a normal person. But I think that is the beauty and magic of BitTensor, is that through BitTensor, through incentives, through everything that we're trying to build, normal people can do extraordinary shit. Okay, cool. So where are we going now? I'm going to bring the researchers to, let me see if they're here or have new jobs. Hold on. Oh, yeah, Yazan. Okay. So let me give you a quick spiel of the problem we're solving now. The final barrier is there's two types of training or decentralized training. There is model parallel, where so there's data parallel, which we currently do, which most people do. In data parallel, each node, each participant in the network has to host a full replica of the model. Take, for example, Templar 72B. We have to run on B200 times 8 machines. Now, this was wild but it means that to join that run, you need a big machine. This is quite good because that's quite a big deal to go to achieve this. Even the hyperscalers admit that it is not possible for them to keep increasing data center sizes. You know that? Because there's some physical limits. It's not all about money. There's time, there's energy. Like how sometimes you cannot even physically route this energy to these data centers. You understand? So they're limited by some hard physical constraints. So they started looking into data center training. How do we communicate between data centers? I'm like, bro, that's what we're doing now. You understand? So, but even for the Google big evil corp use case, our code today, when they eventually decide to do decentralized training, our code will be referenced there. They will ask us to help them fix it. They'll ask us for opinion because we've done it. But for us, we didn't start this to stop there. I've made the mistake of being very unambitious in that when people ask me what is Templar doing, well, Templar is building the state-of-the-art training, and our outputs will be the state-of-the-art model. That's very wrong. We're creating a whole new paradigm here. We're creating a business, a new vertical that's never existed. We will commoditize intelligence. We will commoditize decentralized learning. That is what it is. How do we scale this? It is by saying, okay, we don't care about wherever you compute, we will tap into it. Is it data center compute? Is it your mom's toaster? Is it your MacBook Pro? It doesn't matter. Because you see, all this data center compute is interesting, but the real devil is in how do you get the long tail? How do you harness the masses? All that block compute, it is huge. So when Epoch AI says they're not going to grow as much, they do not see. We've just done our first stage, and our next work, HeterogeneousLoCo, it presents a step function in how much compute we can utilize. Let me give you some feel to understand it a little bit. So basically, what this is going to allow us to do is give credit where credit is due. Understand decentralized. Oh, Amir, cool. Amir, come save me. Amir, come online, please. Come explain the work you guys have done while I keep them company. Okay, so basically, decentralized training is like it's the new wave of it. Initially, Max Rabin for a very long time has been trying to push this, but the technology wasn't ready. In 2024, Google, a guy called Arthur Davis, published the loco by Google, but he never released the code. Then in September, Prime Intellect and Sami Jaguar opened the loco. And this was such a watershed moment for the world because they recreated Google's work and it worked. So that's why me and Cole started working on it. And they started data parallel, which is what Templar has perfected now. And it's good, but it's not decentralized training's final form. Then Lex Long and his friends at Pluralis, they released protocol models. And it's also a very good paper. They are the first people to show us how to do model parallel pre-training. So we stand on the shoulder of child. So what did we do? We combine them. So again, it's not just adding this. We did research. We figured out, okay, how do we have a unified run? It's like that meme, drop the model parallel, drop the data parallel. Just call it training. It's cleaner. I believe this is the apex form of what decentralized training looks like. It's not saying, oh, we want data parallel, what model parallel is. We want to push out. We want to coordinate from across the whole universe even. And we don't give a shit about your topology or even if it's the toaster, if it's a Raspberry Pi, we will train on you. And that is how we think we get to the true form of decentralized training. Hold on. Amir, do you want to tell everyone about the challenges you faced and the main contribution of HeterogeneoLoCo?
The way I think about it is what we solved was the communication between replicas. Each replica is training on a data portion on their own, and they need to communicate gradients together. And what we solved was compressing that gradient and doing it really fast. But the problem is each replica still needs to host a full model. A model that's size 70 billion or more needs a huge amount of compute and it's really expensive. What we are trying to allow here is consumer grade GPUs to join the training. The idea is to fragment the model into pieces that are easily loadable into any VRAM size, load it in your consumer grade GPUs, and then communicate between these servers. The problem is you need to communicate over the internet, which is the actual bottleneck. And we use Subspace Networks. Like there is an idea of compressing those gradients as well. So now we have two different levels of compression. One is within each replica, those consumer grade GPUs communicate in a compressed fashion. When they have trained for a few local steps, then they communicate with other replicas through a SparseLoCo. The SparseLoCo is untouched. What we've changed is like within replica, within your data portion, you now can collaborate with others to be able to train with any hardware you want.
Now, that's what it is. It's been a lot of work. I'm really proud of what the team has done. What does that mean for us? It means we're still dedicated towards pushing the frontier of pre-training. The final product, it doesn't even look like a model now. It looks like infrastructure and services we can sell to create this new industry. Imagine becoming the NVIDIA of decentralized training. That requires two things to happen. It requires us to be the best, and it requires decentralized training to take off. Now, I spoke to someone from the New York Times yesterday. You get instances where you realize how big this can be. Now, I don't think the reporter's going to write about us, but when I explained it, we're like, oh, this is quite good. Now, he also said, who's using this now? And when I told them no one yet, because we're still building it, he lost his interest. And for me, that was a wow. So this guy, we all have different views of when the technology is. I'm on the ground. He's at the news level, but I can see where this technology is going. I can see the world tomorrow where even the hyperscalers have no choice but to do decentralized training. This is so massive because it further reinforces our thesis that decentralized training is here to stay, and we need to double down and create this new vertical. So that's what we're doing now. That's what we are doing now. We really hope and we really thank all of you for our support because it hasn't been easy. It hasn't been easy because DTAO and Tao is trying to find this way. Everyone goes, research subjects are dead. I tell them to fuck off. But we don't have revenue. I also tell them to fuck off because, you see, everyone's fixated on revenue. I don't think revenue is not bad. I don't think revenue is bad. But you need to realize that we're all growth. Even the non-revenue, the potential revenue generating businesses, we're growth companies. When you size on revenue, you have some crazy things happening. Like somebody launches a startup, a subnet, and the first thing is doing is buybacks. Or asking people to over-index on revenue. You're meant to be growing. Even if you're a revenue company, you're not meant to be buying back your token at this bit. But because we're all trying to gain emissions, and everyone thinks revenue is the matter, if we over-index on revenue, we will never be as big as we're meant to be. We will sell out our destiny because what is revenue doing to us right now? The saddest part about this is not even whether people think I should have revenue or not. What is the only thing BitTensor has that is special? It's what we're meant to lean into. People treat it like a cost reduction exercise. No, miners are a resource optimization problem. So when you view it as a cost reduction, then you're not building BitTensor. You're building a Web 2 business, and you're never going to beat Web 2. We are never going to beat Web 2 by doing what Web 2 did. It's not the BitTensor thesis. So this is why I'm not saying don't get revenue, but the revenue fetish comes from how wasteful we were in the root network days. We were just pretending to work and just gaming the system. But I think that we've pivoted so far to the other side that I'm not even sure it's not worse for BitTensor. Because when miners die, BitTensor dies. Okay, cool. Thank you for coming to my sermon, guys. And yeah, we will keep delivering. Thank you for your faith in us. Have a lovely weekend.